hit broadcast.
Is there any
bit of yeah, I think that was it.
Because it was it was such an old system that was based on the original port system, which is
Right.
kind of slow.
So there's that. What else is there?
So
the compact memory usage.
The what?
They're doing the but it's pretty much like we re-C part of Beam. They rewrote in general. Like Beam doesn't have address randomization because if you notice another note, so many registers.
That's cool. Behind me, I guess, or maximize. There's no full screen button. The moment I need it, it's gone.
Can you not just snap it? Oh wait.
Luke, can you say something?
So we're live and we're recording. So you are on the internet.
You guys are on the internet.
Okay. I'm gonna move over that direction. What's that? Moving? Yeah.
I'm moving towards my computer. I wire it in.
All right.
So I guess now that everybody's here and not locked out of the building, we'll start. My name is Jason Goldberger. Welcome to the Phoenix Elixir Language Meetup. We have a guest speaker. His name is Luke. Luke, is it Imhoff?
Imhoff.
Imhoff. He's KronicDeth on GitHub. He's an Elixir expert. He's an Erlang expert. He's very smart, and he works with me at Dockyard. So,
and he makes IntelliJ work really well with Elixir too.
Oh yeah.
Yes.
Cell, I think we do a pretty good job.
Cool.
I've been using Elixir for auxiliary and side projects, both including stuff that we actually use at work and stuff that we don't.
Cool.
My name's Matt. Sorry.
Yeah, we're all making charades.
So I do Elixir full time. I work on their
Real
firmware because they use smart home technologies. So I in their world full time. So I get to work with Frank Hunwick, who created Mirrors, which is pretty fun. I learned a lot from him.
So can you write the firmware in C?
So there's pieces in C, but 90% of it would be in Elixir. So,
yeah. In one of my former jobs, I worked at Cray as a build engineer. So that was like the person that does the releases. So like I had to build the kernel, and we did a bunch of C extensions, and I redid the C build system to use auto tools. So I'm used to doing firmware. Like after TI Basic, the second language I knew was C because TI Basic had a 2K memory limit on the TI-89, but before it got like USB port, and when they still had the flash key, 4-tone grayscale video game graphics because of that.
Yeah.
Nice. We're doing intros, so self-intro.
My name's Engineer. Yeah.
Sure, buddy. No.
Whatever. So I'm doing like build automation. So they have a .NET stack. So I tried to I use Saki to automatically build, and then my friend here, he mentioned this Elixir thing. So then I learned a little bit about it. I watched conference videos. Now I'm here.
And now you're a professional at it.
Yeah, I tried to do a little bit on the whatever that Conical book was, what it was 1.3, the programming in.
Oh, okay.
Like, and then there's the Phoenix one.
Right.
So I've gone through some things. I've done some cones where I did that. I tried to contribute something.
Mm-hmm.
Like I have a pull request somewhere out in the world.
Cool. Way more than I've done.
Call you Mike Closed Source Benner.
I open sourced my first library the other day.
Cool. Very cool.
So my name is Alfredo. I work with Steve here, and it's called software leasing.
Oh,
There's actually 2 companies.
So neither one of you actually knows the name of the company
Yeah.
you're working for.
It's cool.
I just know where to go and the check's clear.
Yeah, exactly.
Check's clear.
It may be a real company, it may not. I don't know. So, anyways, I came to Elixir because I was looking for ways to build software in a non-coupled way, and then so I found Erlang, and that was awesome. And then it was around the same time that Elixir was picking up, so that's why I'm here. I like it, and I'm trying to see if we can introduce it at work. And our CIO hasn't said no yet. He's like, well, go explore it and see where we're at. So
Cool.
that's where we're at.
Sounds dope.
Are you gonna make it to the national conference and do any training, or are you trying to figure it out before?
Evaluating it to see if I mean, not that it doesn't work, but that the business can accept going to a less
Untested.
less known
Not
language.
not .net.
It's a business decision that they have to make, right? And in a case I have to provide, not a technical one.
Dope.
But if we, how much is the Elixir cost?
Early bird just ended, but I think it was like a few weeks ago. It was about almost $500 per seat, and without training.
But the hotel is fairly expensive per night, also. So there's that.
Yeah, because it would be really
Well, that's why I'm
cool if
crashing
they
on your
could get
floor.
them to-
I know you're bringing
Mary
the
got
girl.
that. Mary works for Hyatt. All those days are comped.
Oh, sweet.
Yeah.
Definitely crashing
Yeah.
on your floor.
Very nice. I was like, they let you comp during a conference. And she goes, doesn't look like it's that big. I'm like, we're gonna fist fight after this. No, it's fine. There you go, Mike.
Probably about 60 million pages a month right now that we're crawling to Cassandra back and stuff. And so here we go, working on open sourcing that whole thing.
Dope.
Employer was basically, this process has to run for like an hour.
Yeah.
Do you really want to do that in PHP?
Yeah, I don't know when the last time I shut my beam down at all, and the crawlers are just going.
You
It's
haven't-
been months.
You haven't mentioned any problems other than the really chatty gen server thing you did, and then
Yeah.
you cut that out, and that's
Yeah, and we gen staged the shit out of everything, and that's been amazing.
Well, it's
That's
not
cool.
so much that as the way PHP is built by default. The whole PHP VM goes away as soon as the HTTP request goes away.
Yeah, that's not a language for
Long running process.
anything but web.
that's not a language.
Period.
I'm just kidding. Sorry.
Bad.
Sorry.
It's
I had to make my jabs.
it's bad.
It's great
It's not-
for PHP.
All right, so guys, this is Luke. Today he's going to be presenting, I think, on embedded Elixir. Is that what you
Yes. So the joke about this talk is back channel. People said they wanted to talk on embedded Elixirs.
Luke thinking the PyCam project that the Austin meetup was doing for nerds.
Oh, okay. That's why you.
Yes, because you guys work on that PyCam project at the conference, right? And then
Yeah.
brought it back and then did a hackathon on it, and then
So we could turn on like the filter.
He did the like full JPEG push to
Right. Over
to
the socket.
HTTP, right?
Yeah.
And somebody was watching that with was like, that's a horrible idea, and I was like, it's a prototype that he took like 3 minutes to do. Like, relax, right? Like, yes, he's not streaming compressed codec video. Like, he's just pushing JPEGs, but who cares?
But it's kind of weird. The browser, when you do an MJPEG, like it just works. It's the weirdest thing that like the browser has support for this funky format of I'm going to give you frames as JPEGs, and it just accepts it.
It's a testament to what would it be, Chrome, I guess, or just the browser in general. Yeah, yeah.
I'm just shocked that that's a standard that works.
Right, absolutely. Cool. So, what do you say, Luke? You want to start?
Okay, yeah.
Cool.
So, like I said in that nerves versus other embedded is EE not let me see how to do screen share.
I think I can predict what you're going to say. It has some EEX external preprocessor that takes the @ symbols and parses them into what?
Yeah.
Oh,
okay.
okay.
Can you see? Okay, you can.
Yeah, it's a little small. Actually, incredibly small. And by incredible small,
I got
yeah.
glasses now.
Wait, let me see. I think I can shift it.
Okay.
Okay, so we're gonna stop
Yeah.
for a sec.
Basically, I can tell this is code, but that's about it. Oh, that's better. A little better.
Well, now it's you again.
Yeah.
Yeah. I'm going to move the camera over. I'm going to move it to the smaller screen, and it should pick it.
And it's still amazing that this works at all. Like, I don't know where you are. Like,
Yeah.
Just like we just come into some room,
Right.
connect some shit,
and we're
have collaborative
and
environments.
we're talking across the internet and getting a learning experience.
You're in a tube.
Oh, it is.
We're traveling through the tubes of the internet.
Well,
Okay.
Uh,
Can
still,
you see now?
still
Okay.
super.
no, this was pure
So
fantasy.
what we're seeing is the entire IntelliJ window.
Right, but I moved it to the laptop screen instead of my
Maybe I-
2560 display, so it should be a lower resolution, hopefully.
I'm gonna see if I can zoom in. Hold on, just a second. It is a better resolution, but that doesn't do. Hilariously, if I zoom out, it gets bigger. That's what I always wanted. Control room. You're in a moderated video call. Yeah. Okay. All right. I can't do that.
You can't add anybody else.
Okay,
No.
I can try to lower the resolution and see if it'll work. It might blow up.
Yeah. Let's see what happens.
Which one am I? Oh wait, I have a. Do I have a display picker?
$320 by 200. I can't believe it.
This never would have happened in VS Code. I'm just kidding. I'm only kidding.
Okay, so
No.
we're gonna try to.
Or on Windows, right?
Oh yeah. This on Windows. This would have
Do you
caused
guys-
a blue
do you guys
screen by
use
now.
The Elixir plugin in IntelliJ? And do you like it?
I think Luke works on it. I think he writes it
That
right.
one?
Yes, I read it. Is that better?
Yeah, that's way better. Way
Yes.
better.
Because I
Yeah,
found it,
that,
I was like,
that's
oh, this is
legible, but
great.
the code, obviously you're looking at the same screen as us, so the code is not quite big. Yeah, this is a lot better.
I think we'll be okay. It's kind of distorted.
Okay. So to us, it looks pretty good with the video filters on.
Oh, that's freaky. It's the right aspect ratio when I see what I'm presenting, what you guys can see, but when I see it, it's weirdly stretched because it's
Oh.
not native. That's weird.
That is crazy. Yeah, to us, it looks perfect.
Yeah.
Like,
Well, that's what matters. Okay,
Yeah, cool.
so EX is like here's where EX is assigned in the standard library. So if no one's ever looked at the code for Elixir,
yeah, go ahead.
it's an EX. There's an actual Elixir project that's in the main repo, so you can see the path here. So I have Elixir laying Elixir checked out. There's an Elixir app, and then EX is also part of that. And like the main reasoning behind this, I don't know the reason behind why EX is part of the core, but the main rule that the core team has used for what goes into the Elixir laying Elixir app is what do we need to make Elixir work? And so like they want to be able to test it, so you get XUnit. They want to be able to interactively develop it, so you get IX in there. They want loggers to be available, so you get logger, and they want to be able to run tasks to do it, so you get mix. I'm not sure the exact reason of why EX is one of the main ones, but it just is. But part of that is
I think it's probably that it's the way you would create templates, right? Like it's not HTML specific. If I
It's general templating language
Right.
for
right,
ERB you guys are talking about.
right.
So the main reason why I think it is because I'll get to it, is that in order to make embedded languages like EX and ERB, there's some details of how the parser work and like general hackery to make it work, which means that like the way they wrote the Elixir and the parser has to be aware that such a thing as EEX exists to allow it to work. And like this is weirdly like not just it's how ERB works, I think, and it's definitely how EX works, both in this implementation and the implementation of that I did in the IntelliJ plugin. Like it is impossible to do EX non-cooperatively, and the reasoning for that is that you're allowed to do stuff like this, where you have an if and a do. And if you think about it, if you just did like, I'm allowed to have these symbols, and then I drop into normal Elixir mode, if you did that, it would just bail here and be like, you do is missing end, and it would just bail on you. So they have to be able to call the parser to go, parse up to here, and if you fail post do, I'm totally cool with that. And so if you look, there's actually, trying to think where it is in this code, there's a section where it's actually trying really hard to like recover.
Probably have to know about things like strings too, so that you can include what would have been magic tokens within a string within EEX.
Oh, right, the tokenizer does it. So the tokenizer has this concept of, you could have a bare expression, you could have a start expression. So the start expression is pretty much, the start expression is like, there is an equal sign. So this would parse the expression, but there's also like start of like, I'm allowed to see ifs. So like, this is a start, and this is a middle of like, in normal Elixir, you couldn't just have an else bare there because it would blow up of, like you need to make sure that there's a new line. But if you think about it, this, if you just took the chunk of like, I'm going to eliminate the space around this brace, that else can't see that you actually new lined around it. So that middle expression weirdness is actually keeping track of like, in normal Elixir, you would need a new line here, or this isn't going to parse right. But in EX, we're going to allow it under the assumption that when you did these braces, it counts as a new line even if it's not there. Like you can do weird things, like you could completely eliminate this and it would still parse in certain situations because it's just like an implicit new line because you're switching languages.
I see. So what you're saying is the beginning of the EEX expression, less than %, it basically infers that, or it implies that there's a new line in front of that else.
Right.
Okay.
Because what it's really doing is it's going to take this code and then it's going to compile this to just a bare string. Now, EX, to be super efficient, doesn't just do a string. It actually does it as an IO list. So it can knit these together more efficiently to print. It's one of the reasons why why it's a viable option to do server-side renders again when we switch to Elixir, is because these templates become IO lists. And what the IO list means is this becomes a constant. And that constant doesn't have to be concatenated into a giant string the way you would in most other languages. There's at least it's a Linux call. I don't know if it's a POSIX call called write_v, which is write vector, where your user space addresses for each of these strings, it can be passed along, and anything that needs to do IO, like printing to a terminal or a pseudo terminal or logging or over a socket, can just grab those and they transition into kernel space because all those IO systems have to go through kernel space. And then they would really efficiently just pipe out without you having to construct one giant buffer in user space. And that's why we get the microsecond response time, while most for our templates, while like a full, access the Phoenix and get the render back, as opposed to in most languages, you're going to get millisecond response time for that. So if you look at the tokenizer, it's going to fail. So like here, it's doing errors and it's slowly picking up. The tokenizer is written like every other tokenizer where in Erlang, where you can just pattern match the beginning and keep going. And it's doing character lists because that's how the internal parser, the internal tokenizer for native Elixir works.
Very cool.
Yeah, and you also look, it's a list in reverse. So like it's doing some optimizations where it knows it's in a reverse list and it's just going to pattern match directly. So like this is pattern matching on do, but it's odd because it knows it's in reverse at this point.
So this reversing the entire like source code lets them walk backwards.
Yes.
efficiently.
Yes.
That's hilarious. I've never seen this
Well, no,
before.
it's just for the token name. So like it is keeping track of the token name, an accumulator. But instead of reversing and then pattern matching, since it knows all the expected patterns, it's just like they were just like, I'm gonna write the pattern in reverse and it'll just work. This also depends on
Sorry,
So-
I like the arrow on 123. How it's not an arrow anymore when you reverse
Right.
it.
And so in my view, this actually looks conjoined is so in IntelliJ, I'm using Fira code, which is a modified of Fira or Fira Mono font that does ligatures. So
Okay.
anything that could look like a math symbol, it automatically joins it into one grapheme. And so it's really cool because it it makes our pipe symbol actually look like a pipe and cool stuff like that.
Right.
And so here it's joining those together because it also works for Haskell, which has way more arrows. Other weird things about the pattern is, even though when we're like conjoining lists, they're like, don't use plus plus. Plus plus is allowed for patterns and it's efficient because it realizes that this, as long as this is a literal list, it'll be cool with it because it knows how big the list is, so it can pop out those sections of the list without actually having to completely walk the list to just grab the first two.
Would that work for any pattern that it can determine the size of?
Right. So it's the same thing with binary pattern matching where you can pattern match at the beginning because you know the fixed size. It can't pattern match in like at the very end I have some suffix. That doesn't work with pattern matching because it always has to be that sort of constant time scan. The only weirdness where like even guards don't have constant time is like length for lists is allowed in a guard, even though that's not constant time. And like pre-calculable how much time it would take. So like here you see it matches, it's got the token, then it reverses it because like, okay, we're good to keep going. Here, this is where I was talking about that coordination that YEX is here. Is Elixir tokenizer is the tokenizer that Elixir is using natively when it's parsing your normal .ex or exs files. And so it's going to, at that arrow, so this, is like a anonymous function arrow or like a case arrow, it's going to take what the internal language calls a stab, because literally we use stabs to say it. We use stabby arrows to do it. So that's called a stab. And
Good.
what it's doing here is that bare stab wouldn't work normally. So what it's doing is this check terminator is turning off. So most of the checks that would normally check for like your code is invalid, it's turning those off and then doing extra logic to scan ahead of. So you see here, we're like, if I don't get a terminator, I must be a middle expression. So this is how it's handling the else stuff of like, or you're doing multiple clauses, is if there's an error, I'm not going to throw a grammar error. I'm not going to throw a compile error. I'm just going to assume you're not done yet for the bat.
So does that mean later on? Does that mean later on it has to make sure that it paired all of the do's with an end? It doesn't just.
Yes.
Okay.
I'm not sure if it does it at the final parse or if it does it on when it converts it to real code. Yeah, here you can see all the other keywords.
Right. DNE. There you go.
And rescue.
Oh yeah, DNA.
And expression. Right. I see. So it has to. It's probably going to check that every single start expression ends with a end expression, which is cool.
Yeah.
Yeah. Okay.
And then it has to check for spaces because it's most tokenizers try to not care about spaces, but you also don't. For EX, you kind of don't want the stuff shoved next to the percent symbols because it would read weird. And in some cases, make it look like you're doing operations, like you're doing less than, and then, percent operation, like trying to start a struct or a map. And so it has to do these extra checks that in a normal tokenizer just kind of happen linearly and you don't have to go back and check your work. So there's a little backtracking, but it's very efficient otherwise. Try to think if there's other gotchas that make this interesting, but that's mostly it. So going back to my original point before I brought up the code was that the default. So there's the default engine for EX does not know about @ symbols, and it does have
You mentioned this. So so just to recap, in Phoenix, when you want to access something that is in the cons assigns, you would @symbol that the name of that variable.
Right.
Right. Okay.
And so you're like, well, okay, where does that happen? Oh, so there's engine, there's smart engine. You look there, you're like, oh, here are my @symbols. This must be what Phoenix uses. No, it does not. Phoenix does not use this. This looks like Phoenix's stuff with @signs, but it is not that. Instead, what Phoenix's engine is in Phoenix HTML. Oh, it's on the wrong screen. Let me pull it down. In Phoenix HTML, there's an engine, and this engine is what actually does the @symbol handling. So going back to the Elixir one, if you look here, so just to make the @symbol handling, because they knew they'll need it, the default engine has this completely useless callback called handle expression, and it's only there because they knew that Smart Engine and Phoenix engines would want to do this weird thing with the @symbols, or in general, allow for injected variables where you didn't have to do a function call. And so for that, they actually have this handle expression callback.
Hold on, Luke. Give me
So this is a default implementation that essentially does nothing. And then anybody that really needs it, they must implement it. And then because it's all functional, it's just because it's in the namespace, it replaces this with the one that I'm using.
Right. So you could safely call functions. Oh, so I probably should explain that. Is that EX doesn't spit out an independent file, and you don't call it every time. So just like the way the ILS are an optimization, the way EX works is it is a compile time thing where that template becomes real functions. And so to do that, you can see right here where it's doing the call EX function from file. So if you look at that.
Oh, so I see. So you give it the type of function that you want. In this case, it's a def function. It's not a private function. And then you give it a name, which is just an atom after that. And then you give it the file it's supposed to look at. And then what's A and B? Is that the args that are supposed to be given to it?
So this is saying that I think it's grab from assigns. And so so.
Oh no, yeah. So that's what the variables are called.
Right. So A and B is here. This is here. So you're passing it in. So you're making a function called sample that takes in a keyword list and does that. The assigns key is trying to think where it explains that.
And this is still in. Sorry, this is still in EEX. This is not
right. This is in EX. It's not even in the Smart Engine. It has support for this. It is EX jobs, not Phoenix's, to handle. I'm going to take this code that mixes together some outer template language, HTML, text, whatever, and take these weird angle brackets and turn everything that's outside the angle brackets into strings, and combine that with the normal Elixir code you wrote, without you having to, do a bunch of here docs with triple quotes to try to do that.
Right.
And so because this compiles to a function in a macro in a module, anything in the body of sample already would be accessible. So you couldn't, without having the A and B for the assigns, you wouldn't be able to access A and B as those @symbol variables. But if you had a function in here called A, if you did def A inside of here, and then you called A as a function with, as a bare variable or with parentheses, as you should now, that would work just natively without the Smart Engine, because that's allowed. And it was, mostly it was just this is how it looked for ERB Rails templates, so they wanted to use the @symbol. But I do kind of think it's confusing because they're not module attributes.
Right. We use ats for module attributes in normal Elixir, and then when you go into EX, you have a special case to access variables.
Yeah,
which is weird. It's weird to me too, where it's just why don't we just call this a normal variable?
Yeah, and I want to say the reason why we don't do normal variables, it makes the resolution harder. Like using a special variable that you know isn't allowed makes it easier to walk the tree for handle expression. Because otherwise, every variable, because you're walking the tree before the resolution happens, I think, you wouldn't know that it's an unresolved variable or if it's a function call that needs to be resolved. But I'd have to double check how it walks to be sure if that's true.
So sorry. So you're saying that when it encounters it, sorry.
But back up. I can answer that question a lot simpler. The Elixir compiler has to know whether any particular symbol is a variable or a function call before it emits beam code. You know that, right?
Oh, yeah, I know that. But I meant at the handle expression level. I don't... That you're still parsing an AST, and I don't know if the macro pass to resolve variables has happened already when the handle expression callback in EX is called. Because I haven't walked that code.
Remember that the assign map is a map or a property list, which means that the set of stuff in it is decided at runtime.
Right, but you're also not supposed to...
Well, you're not supposed to inject stuff into it at runtime, but you can do it because of the way the API...
Yeah, I'm trying to think. Right, the thing they changed in Phoenix is that it blows up instead of giving you nil when it's not there, but it doesn't actually decide ahead of time that it doesn't double check that you're passing the right assigns.
Right, right. Because the assign is a map and is composed at runtime, so the set of stuff that's in assign, it doesn't know that at the time when it emits beam code.
Well, yeah, but you could do it the other way because, like, you could see all the assigns in the template because of the ats, and you would know it's just using at was convenient for that as opposed to leaving... Instead of having the Elixir code like conditionally compile where like if you're unresolved, I'm just going to assume your assigns, would actually probably be more confusing because you wouldn't know something is coming from assigns then. So it also helps humans read the code of like, this is special, it's coming from somewhere, as opposed to the other way where you just have to know that you don't have a module imported into your view to give you that data.
Got it. So you're saying like if we just had an A and a B floating out there, you would never know where it came from.
Right. So if you did the bare no parentheses calls, you'd have the whole problem of is it a variable or is it a function? But then just from like this is a compile time thing, you'd really like to be able to check the work at a time and just read it of you as a human or the compiler would just have to say like, if I can't figure out where it comes from, oh, it must be an assign and I hope it works at runtime.
Right.
While with the ats, it's like it's completely unused. You don't expect to use module attributes in a template language. And so it's okay because you're not like module attributes are useful to kind of get around the need to do unquote gymnastics when you have like stuff inside of a def. And so you don't need to do those tricks in a template language. So it's a useful thing you're not using. It's sort of like ecto using pin to mean interpolation.
Right, right.
And the main reason I think that ecto uses pin and not actual interpolation is because the interpolation is part of the tokenizer. So it'd be really difficult to fuck with that part of Elixir.
Yeah.
While doing the pin just shows up as part of the AST, and so it's easy to mess with.
Right. So without the pin, those things show up like they're atoms, right? So you're like, what's what is this thing that I'm dealing with in this AST?
Right.
Doing it the way you described it without the at sign in EEX would require them to have EEX messing around in the Elixir name resolver.
Right.
Which right now they don't do that.
Right. And so it seems like the only affordance that the normal tokenizer gives is the check terminators part that I showed previously. That's the only affordance that EX needs. So it's like the minimal change to allow template languages, and it's probably the safest change. It is, kind of weird that they just have to be like, if I get an error, I just assume I'm a middle expression. But it seems to work out. I haven't pathologically tested EX to see if I can break it, like I have with the normal native. So
I've used EEX and template injection a ton, and the biggest problem you'll run into is like, are things that you've done wrong as a programmer, like passing the wrong module or passing the wrong template around, or not giving a template the arguments that it's supposed to have, like the keyword list args. You know what I mean? So
yeah,
that's it. Nothing crazy. I've never seen anything unexpected come out of an EEX template.
So like I said, Phoenix doesn't use Smart Engine. What it does is it does this Phoenix HTML, does its own stuff. Most of it is pass through. One thing it does add is it adds the support for the safe HTML support. By the safe HTML is just tuples of like the IO list, and now it's safe. Like Rails version is there's a special object that is HTML safe. So ours is a little bit lighter weight to do that.
Only a little.
A little bit.
No, a little more than a little, but yeah.
Yeah, because Phoenix's EEX templates are supposed to escape HTML unless you specifically ask them not to. And obviously a general purpose templating language that isn't specifically for HTML shouldn't do that.
Right.
Yeah. It does mean that, well, one thing obviously with EEX is that the angle bracket syntax is fixed. So the logic of like, I allow like ifs to be interleaved with code for like a slim or handle or hamel or handlebars. They all have to do that sort of logic from scratch, and they have to hope that they can write their tokenizer completely on their own, or that the check terminator's false is enough to make their language work. So like EX is not enough to support all template languages. It's just enough to support one that has angle brackets and either no tag type or like percent and then an equals. And they also added a verse where someone requested that they allow pipe so that someone could write their own custom extension to the language, but that's it. Like EX is kind of fixed with the tags you can have, but it's also really simple for that reason. Like the code is hundreds of lines, not thousands.
Luke, in your opinion, would it be beneficial or even possible to change the delimiters for EEX?
Like you mean, so it's not angle brackets?
Yeah, so we're not doing angle bracket percent equals. We're doing like double handlebar mustaches, right? Like, do you see what I'm saying? Like, I don't know if that would be recommended given what angle bracket means. Sorry, not angle bracket, but mustache means in.
So you want to make it like a Chandler underscore?
Yeah, like what would it take to make mustache, right? Mustache Elixir, and make it an actual like supported thing, or more specifically, is the tokenizer? Should the tokenizer be have a using macro, right? Where you can tell it like, here's your configuration. See what I'm saying?
I mean, so Phoenix has support for changing the underlying engine, but that mostly changes what the outer language is, like, whether it spits out HTML or it spits out PDFs and that sort of stuff.
Got it.
But yeah, you can't change the angle brackets. But like I said, like, what, this is 200. That's only 40. That's another 200. So yeah, it's like 1,000 lines of code to mimic it.
Got it. So it's nothing super heavy. It's just
no.
You can figure it out, or one could figure it out, I should say.
Yeah, I'm trying to think like where it cares. Yeah, so here's these lines of the tokenizer is what tells it these are supported edges. So just inside of tokenizer, these few patterns is it that defines those.
Got it. So I'm looking at this, and you could literally just apply like overrides to this callback.
Yeah.
And here's a new templating engine for Elixir.
Yeah, it's unfortunately not.
It's not quite that
pluggable, but I mean, it's also debatable whether if you just are changing the angle brackets, if it would do anything, because like handlebars has a much more you know, like how you conditionally include blocks is a slightly different structure than just like an Elixir if. And same with Slim, like there's different ways to signal conditionalness that isn't pure Elixir, and so that's why you might have to do your own tokenizer.
I see. Okay. Cool.
But it's such limited code, like, yeah, unfortunately to change it right now, because like it's both in the pattern and then replicated down here, but in reverse, that you end up you know, having to copy all the code and just doing the changes you need to tweak it. You know, because here's the markers. Like it's replicated a bunch of spots, so you could.
I'm like Luke. This is me right now. I would just solve that with a macro, right? Like to be honest, like so, the macros in this language are flexible enough that you could take a pattern forward and turn it into a pattern backwards, right? Even if you had to figure out how to, because I'm not quite sure how to at the moment, turn a character into its integer of a char list, right? That makes sense. Like they do question mark. They do question mark %. I'm not quite sure how to turn, off the top of my head, like a slash into the integer that it would be in a char list, but can't be that difficult.
Oh no, it would be literally just that character. If you had the list and you just took that element at that, it would be literally that integer, because that's how char lists work. The reason why it has to be question mark and not this, because that's, you know, that's a list of
right. That's a list of those, right? You'd have to flatten.
So if you just had a 3 list of these characters, like this thing here is actually the same as, you know, equals
slash, yeah, pipe, right? Got it.
That is that right there. But this kind of makes it more like, yeah, you could do that, but it's kind of dickish to the reader to write the code that way, because it's not obvious that what you're doing is you're saying, as a list, I want to be one of these things, as opposed to like, I am scanning this char list looking for a substring, which is not how in works.
Right. Oh, I see. Yeah, you think somebody would mistake it as looking for maybe multiple characters. Got it.
So it's not looking for
it is
a star or a / or a pipe?
Yeah, it's looking for an equals, but yeah, it's not a star, it's an equals on there.
Right, so like all EX tags start with, you know, angle bracket %. If you do angle bracket %, it's sort of like do this without side effects. If you do it with equals, it's take the output of this value, this expression, and it becomes what you print. And then the pipe and slash are like ones they add on because someone like a while ago now, it's been years. It might have been right before 1.0 said, hey, I want to do these extensions. Can we just put some gimme characters that I can use for other stuff? And they're like, sure. It's the same reason that if you go into
sorry, so Luke, you're saying on line 82, the reason they have a backslash and a pipe is because somebody wanted to do more with the syntax, or like
so they want pipe. There's actually there's an issue about it. Now, mind you, it's years old and probably really hard to search because there's a bunch of symbols you're looking for.
Right.
But yeah, that's why those are here. Nothing Phoenix or EX uses that stuff. It is just there to give someone something to grab onto to do extensions to EX.
Weird.
Yeah.
Super weird.
But there's other extensions. So like in native Elixir, so this Elixir parser is, there's 2 levels to most language parsing. There's a tokenizer, which is like, I find the words in your language. And then there's words and operators. And then there's the parser that is, how do I turn this into an AST? And so right before 1.0 happened, like there was pipe. So here you can see Fire Code merging them together into an actual like triangle. So that's kind of cool. But so these are used for bit operations, but there's all these other arrow ones that were requested just so that people could do weird shit.
In macros.
No, because these are operations that are expected. Well, okay, yes, you need to be able to do them in a macro. That's true. It has to be something that eventually gets parsed as AST first, because they won't be real operators.
Sorry, are are you saying to me right now that triple arrow to the right, greater than, and pipe can be synonyms if I'm not using
No. They're not synonyms. You can define operators. So like,
bro, what? I was like, I'm extremely surprised I've not seen somebody screw up a DSL with this.
so
Right, part of bitwise. Okay,
right.
right.
So bitwise, those are the shift operators because Erlang has bitwise operators, but they're words that are infix operators. So like they have a bitwise or, but it's like between two variables and or, and that screws with our word or.
Right.
And we didn't want to say bitwise or like b or, which is how and band like this, which is how all of the so like band exists in Erlang, but you would do int band 1. So it'd be an infix operator that's a word for other bitwise stuff. So it reads differently than the Elixir stuff. And I guess this was just so that it looks more like Java or C or C++, where the shifts and stuff, the bitwise stuff uses the symbol operators.
Got it. So what this is defining the special forms then, like allowed special forms, even though you might never use them.
Right. So this is all the things that will be accepted as operators.
Do we know what the squiggly double arrow to the right means then?
No. This is the same thing as the pipe and the slash. That's why I'm talking about it. Is that it was something added because people are like, hey, could we have more operators to do weird shit? I do know some of these arrows are used by the what is it? Is it Witchcraft? It's the library that ports like monadic do and other Haskell stuff. They're using the arrow operators.
Right. I actually saw that repo a few weeks ago. Looks pretty cool.
Yeah. Now, the fun part about this grammar file is, so we've been Elixir 1.0. Has the grammar ever changed in the 1.0 line?
That's a good question. I would say no, but I would probably be wrong.
Oh, it totally has, because I have to keep up with it in the plugin, and it's super annoying when so some of it is like it's a bug fix, so you know that like thing where like you can violate semantic versioning if it's a bug fix, but like this not
where
sorry, I keep clicking on the view, other view. So this not has shifted its precedence back and forth, like what group it's in. This 3-op used to be grouped with other stuff. Not in didn't exist, of course, so that's like an addition, so that's kind of okay for compatibility.
Wait, how is not in not parsed as unary in? Like
they do special handling.
Neg unary in is that not a?
They do that first.
That's weird.
Right. So, but weirdly, nothing else is ready to handle it. So, like, there is no not in operator. What the grammar actually does is it sees not in and then constructs the AST like you said not, and then parentheses in, because parentheses aren't in AST. So like it's just a thing they added because it's a really nice way to read it. And also the other way, there had to be special parsing that if unary not and then a in happens, that the in wins, so that it applies to the whole in operation and not like not A in B as in not A in B.
Right. So not A being false or whatever, probably false, right?
Yeah. So either way, it was weird. It was weird how it had to be handled. But not in at least reads more obviously to be what you mean. And that whole not in thing has been adopted in other languages. So like Kotlin now has not in or not is to do like anti-instance checks. So it seems to be caught on in other languages. I don't know where Elixir picked it up from first. I think it was from another language, if I remember the issue request for it.
I mean, it reminds me of Python, to be quite honest, but
yeah.
So
cool.
I'm trying. So that covers like weird things with the grammar. Let's see.
And
So
see, supposed to have a space in between not in because you could have put it all together and
Right.
it would have been a brand new thing
Not in, not underscore in or something
Or-
crazy.
or a bang in.
The ones that are really annoying is unary versus binary add. Like it has varied like whether you, like where is your new line and how many spaces you have has varied. Like they constantly are keep changing of like the different rules of like, well, when we read that as a human, no, we mean this to be because of the no parentheses call. If you do A space plus space B, you read that as A and B are siblings and I'm going to add them together. If you do A space plus B, no space between the plus and the B, that looks like A is a function and I'm going to make, if B is negative, I'm going to make it positive, like kind of like the absolute value of B first and then call A. And so that
I like Michael's reaction there.
Plus
no,
B. Plus the B.
I don't know if you heard that, Luke, but one of the guys here was like,
yeah, like that is the most annoying thing. And especially because when it's confusing for Elixir's native parser is different than when it's confusing for my parser IntelliJ because they're different ways of writing parsers. But like that variance has been super annoying to track, like when they've decided to fix it and when to not.
Sorry, so Luke, if I understand what you just said correctly, you're not using this elixir parcel.yrl.
No, because it gives up immediately. And that's not what you want to happen in IDE.
Okay.
So like we want the like the type of compiler Elixir is, we want to blow up immediately. It's not the type of like C++ compiler where it gives you like 50 pages of template warnings. And so for that reason, it immediately blows up. There are some affordances. So like there's a couple rules that are specifically there just to make pretty error messages, but it's still like as soon as you can't parse, it stops. While in an IDE, you kind of want to be able to type code, but like still do completions and stuff like that. And so like you kind of need to not have the rest of the file get borked when you're editing the middle of the file. And so this type of parser,
somebody should tell Elixir LS that. I'm sorry. Sorry to pick on Elixir LS. I really do like it. It's just
right. So they have the benefit of they always match native. But then they also like they don't have a error recovering parser.
right. If it's the first warning you get is the warning you get until you fix it and recompile. So
yeah. But it's much easier for them to develop. Like
sorry, give me 1 second. It's a add-on for VS. Well, it's not an add-on for VS Code. It is an Elixir project that parses. Sorry, it's an Elixir backend for an IDE, right? So in the background of like VS Code, if you install VS Code, it will attempt to build your project and then output the error, or attempt to statically analyze your project with Dialyzer and output the error in VS Code.
Right.
It's usually really helpful
it's not.
until you make a mistake in your code and compile it, and then it sits there and says, this is what's wrong with your code, and you have to go fix that one thing, and then it'll retry, and then it'll be like, oh, all this other stuff is wrong too. So it's not as helpful as something that Luke is describing, which is where you want to parse parts and determine what's wrong with the parts instead of the whole thing.
He has more tolerance than the real thing.
Right.
And that's why he has to do it, because when you're in the IDE, I need to be helpful to you.
Right, exactly.
It's probably also faster the way he's doing it, because you don't have to call out to another process.
Not necessarily, because my grammar has to try. So getting very into the weeds about it, this URL means it's using Yak. Yak is an Erlang version of Yak, and Yak is yet another C compiler or compiler. So Yak is in LALR. So that's look ahead, left to right. So that means, can you see me or just the screen right now?
Just the screen.
Okay.
I think I can see you in the corner.
No, that's us.
That's
us. Yeah.
Okay. So let's see if I can. I don't know if I can bring myself back.
You have to stop sharing screen, I think, or stop presentation.
Well, okay, I'll just explain it. So like, it parses the code left to right. You know, the way we read English. That's great. But when it actually figures out like, is this a do block? It's actually trying to match like the grammar rule of that by going from right to left. And doing that, the parsers are really compact and really efficient, but there's no way for those generated parsers to tell you, well, if you just gave me an end, I'd be able to keep going. Like if you look at the generated code for the parser, there's no way as a human or even as the code to tell you what got wrong. It's just a really compact, really memory efficient parser, which is great for really fast compiles.
Got it.
But so like to have an error recovering parser, you need to go the opposite way, which is an LL parser. So you're going to read from left to right, but you're also going to match rules left to right. So there were some caveats with that. It took me a year to get the grammar right in the plugin. That's because first, I didn't take a compilers course in college. I did CE and electrical engineering, so I missed the senior year computer science. This is how you make a compiler course. So this Elixir URL is, in theory, in Bacchus normal form or Bacchus nor form, where you're like, this is how you describe a grammar. No, this is how you describe a grammar specifically for YEC. When I first tried to parse just these rules, they go into an infinite loop in an LL parser because in LALR, you want the rules to immediately dive down recursively on the first element because they match from the opposite side. So you want a terminating thing of like literally the word do on the right right end for these rules to terminate. While for an LL parser, you want them to immediately terminate at the beginning. And so like it just went into an infinite loop, nothing happened. So like in the very beginning, I could parse numbers and I could handle when you like used hexadecimal numbers without it. It took a long time to get it right. Because of that, because BNFs are not like this is a universal language for grammars. It is very specific to the one you're going to generate.
How you do this grammar, this exact grammar that is this exact version.
Right. And so like even if you get rid of this build list stuff, this would only work for an LALR with the same affordances. So like there's affordances in here of like you can say the precedence of operators. There are generators where you don't do that. You have to actually list them in the right order to simulate that precedence. So if we go,
no, he's still here.
Okay.
Luke,
I'm pulling down the other one because everything pops up on my main screen, so I have to pull it down to the screen to do it.
I'm trying to remember when I dealt with Bacchus normal forms before. I've dealt with it somewhere, and I'm trying to recall, but I can't. So
yeah, I did it for some computer science course, and it wasn't compiler design because I didn't take one. So there was some reason to learn it. I think it was a generalized like thinking about how computer programs parse programs to like just so you kind of understand like why you need parentheses and stuff. And so this grammar,
It was hard for other people.
yeah.
That mostly seems to be the problem. That is also says it's BNF, it's Bacchus nor form. Of course it works for everything. No. So this isn't even an LL grammar. It is a grammar that works specifically for GrammarKit, which is a grammar generator that IntelliJ made that you are allowed to use. A lot of people use the one that starts with an A. I forget which one it is that's popular with Java. I can't remember what it's called now. Antler. A lot of people use Antler too. But it has an affordance where there was this, I think it was in the 70s, because all great computer science happened in the 70s and we just forgot about it. Say, like Lisp, is that what it does is if you have match expression here, so if you have some term here, some rule, and you then inside of another rule on both sides or on one side or the other put the same rule, it'll notice, oh, this is an operation. Because it turns out that this is one of those things that is like provable, or like as far as we know, there's no way to convert an LL grammar to an LR grammar automatically. There are just a bunch of ad hoc things by hand. And so one of these things that was figured out was called a Pratt parser. So if you Google for it, there are like 3 hits on the internet. There's the like paper from the 70s, and there's like someone from the 90s that figured out how to do it in JavaScript, and then like one thing like a little more recently.
And
So
then
this is
with your one document.
No, it's all good.
Oh, great.
So
Where's
Luke,
that?
I'm confused on what I'm confused at what I'm looking at actually.
okay. So
What am I looking at, Luke?
This is IntelliJ Elixir's parser.
What
So
language? What language is this written in?
Grammar kit.
Oh, geez. Okay. All
this
right.
is the BNF grammar kit one. So every grammar is different. So like if you're trying to make your own EX, how you even write the parser will not necessarily look the same as another language. So like you could just model an EX and I'm going to write the tokenizer by hand. That's perfectly valid. So the tokenizer, so in C, the 2 pairs for like the like writing compilers is there's Bison or Leaks or Lek for doing the tokenizer, and then Yak, which goes with Yak for the parser. But in Elixir, they didn't use Leaks. They actually just did it directly. So
I just remembered how I encountered Bacchus normal forms. I was trying to write a client for Kafka. And I looked at one of the Erlang projects that is a client for Kafka, and it uses Bacchus normal form URL templates. And I'm like, I am not going down this rabbit hole. And it took me like a day to decide.
did it feel Kafka-esque?
It felt horrible. I was like, I would rather write this by hand. I basically decided I would rather write a grammar by hand, like just by parsing an AST than to do what they were doing.
So do I have to go to like a whole course about compilers and stuff in order to even understand this? And do I have to like fail it twice?
Maybe.
Maybe.
Yeah.
So like I said,
Yeah.
He had a passion and it took him a year.
Yeah.
And he had a problem to solve.
I mean, that's really what's going to happen. Like, if you come up with a new language, or it turns out that like there already is a Slim support, but like if there was Slim or Sass and it wasn't supported and you really want it, you would have to know what you're doing, or get lucky that like it's easy to parse using pattern matching with just like a tokenizer. Like you don't have such. It is possible to have a language so simple that like the tokenizer is enough, and you just get a list and you kind of walk it and it just works. Elixir isn't that way, because that nice thing where we don't have to use parentheses for everything that we inherited from Ruby is a pain in the ass to write a parser for. Because every single variable you have to be like, well, maybe I could group everything in. And it also has the weird thing of like the do matches to the outermost thing. So like if you have A on the leftmost, the do matches. While any compiler book you read, it'll say that you must do an LL grammar to get this, or just force your people to use parentheses, and then you don't have this problem. Like it's one page of, hey, that thing Elixir and Ruby does, don't do that, it's hard. So there's no explanation of actually how to write languages like Ruby and Elixir where parentheses are optional. Haskell doesn't have this problem, because Haskell is just like, we always group. You know, like you have it really only has one argument, then you have an argument, it curries. So like Haskell doesn't have this problem, but when people say that Erlang is more complex than Elixir, it's because they haven't tried to actually think about how you parse them. Like Erlang is such a more simple language because there's only so many things to do and so many ways to parse it.
Right.
Well,
So if they had mandated parentheses early on, then it would have been easier. But because parentheses are optional and they can't deprecate that, like could they make a Elixir 2.0 and say we're no longer gonna,
You could deprecate it. It would screw the code base up for a little while, I'm sure.
Yeah, it would mostly be whether everyone would throw up their hands of like
Abandon it.
the things that people think of as keywords. So like I fought this for a long time of people that use the other plugins were like, why is def not highlighted as a keyword? Why is def module not highlighted as a keyword? And I'm like, it's not a keyword. It's not. Like people thinking it is makes people think about the code wrong. So just as an example, if anyone didn't know that, if you look in, let's see if I can find it, in kernel.
Def is a macro.
Yeah, so if you do, well, more confusingly, def macro, no. Def macro is a macro defined with def macro.
That is impossible.
Well, okay, so they cheat.
Sorry.
There's a bootstrapping pass where this import says, don't try to get this shit, and then go to Elixir bootstrap.
Oh, I see. So you bootstrap it first. I'm like,
Yeah,
I actually said that's impossible, and then I was like, actually, I might be serious. I might think that's impossible. But
well, this is where once you're down the rabbit hole, I like to use the language. I no longer like I'm dumb. I just need to get shit done, like make websites and collect money, and like this is like what?
Knowing that def can be overridden though is useful because if you ever do a def, if you do a def impl for a protocol, the def you're using is not a normal def. Protocol itself defines its own def, and that's why like you write a def, but it's really like a callback signature because that's you're allowed to override def. If it was a keyword, that wouldn't work. It would have to be like some weird thing where when we see def impl, that's a keyword, and inside that do block, we know that def actually means I'm going to define a callback. And instead, they were able to write that in language, which means you can also do weird stuff like that if you really wanted to.
So that's why you don't highlight it the quote unquote correct color, where they believe the correct color would have been a keyword color. But
Yeah.
you make it the color of macros.
Yeah, so what I did was I made it so that it's kind of itchy, but I made it so that the built-ins were the same color as keywords, orange. And so like I'm like, fine, everyone wants it orange, I'll make it orange. But like that's why length is also like length isn't a keyword, it's orange. So orange is like my built-in color.
Huh.
And bold is just like it's a macro. While this is like it's a function. So it's orange but not bold. Oh.
So can I ask you a question? How do you do IntelliSense? Because like your IntelliSense is different than, and I don't want to be disrespectful, but the VS Code IntelliSense, and I don't know whether like IntelliJ doesn't do something and then you can't hook into it, or whether
No. So the way that IntelliSense works is it's using the language server. So language server is a standard that Microsoft came up with for TypeScript, and like because TypeScript came out and like TypeScript was the best in VS Code. Like that was both when VS Code came out and TypeScript came out. And instead of like making it a plugin that only worked in VS Code because they want TypeScript to also work in Visual Studio, and they knew VS Code was going to be installed on places that didn't, that weren't Windows, they came up with this language server where you can write your language tools in the language and then have a text protocol. I think it's mostly text to talk back and forth, and that allows it for you to use your native tools. But with the Elixir language server, it is using literally like Elixir to do it. So if Elixir can't build your code, it can't analyze your code.
Okay.
So what I'm doing is I'm using the libraries that IntelliJ has to, given you have an AST, which for IntelliJ, the background stuff is called PSI elements. So if I go...
Sorry. So what you're saying is VS Code uses Elixir itself, and you are using something else?
Yeah. What I'm using is it's just the library. So this Elixir grammar gets into an Elixir. that generates this code. So this is a generator file, blah, blah, blah. And so what it does is it's going to parse it and spit out this entire AST where everything is a subclass of a thing called a PSI element. And so that's an AST that I can actively walk. And I'm just walking resolve stuff. I'm just walking that that tree. So like trying to think where's it good. So there's a system called oh wait, I don't want that case. Called get reference. So what get reference does is, you know, say a usage of a variable. You know, you have a equals 1 and then you have f past a, and I want a to highlight as being used. So as an example, here I'm using address. This address has a reference to this address. And I'm doing that by actually taking the PSI and using the rules I inferred from how Elixir natively resolves stuff, walking up the tree. And like going up here and like, okay, you're in a function call, find the previous sibling. Look here, were you previously here? No. Okay, go to the next sibling. Look here, no. Look here, okay, yeah, that's 1. So it's doing that. And then this whole thing of where it's like the green and red, that's the highlight usage system. So by using the tools of like get reference, the other parts of IntelliJ kind of just come online, and I'm able to get this other stuff. Now, part of it is Elixir is a weird language that's not exactly like Java. So like it's write once, and like when variables are redeclared, you're not writing to the variable twice, you're really declaring a new variable. So some of that I've had to fix by hand. But I'm doing that so that I can resolve stuff when your code's a little bit broke.
Got it. I see. So right. So the Elixir parser was built to. Sorry, the Elixir parser was built to build valid code into bytecode, and yours is for using an IDE.
Right, and it also throws out some information. So, okay, so here I'm aliasing block. Let me
Are you on? Sorry, this is off topic, Luke. Are you on POA right now?
Yeah.
The project, cool. I didn't.
Yeah,
know.
I'm as far as I know, I'm staying on until the end of the new contract extension. I'm just at the start of July, I get to I'm switching to Mana, which is their like EVM in Elixir project.
Oh, okay, awesome. What's that? No, this is the other. There were 2 blockchain things that were going on. I'm working on one, and this is the other one.
Yeah, so POA is completely open source, which is why I can show everyone this.
Right.
Like
right.
they actually got like a $250,000 grant from some foundation that Ethereum has to make an open source Explorer, because the current one is closed source. And you know, people are a little bit paranoid in the blockchain community about, you know, having the equivalent of like their bank software be closed source, where they're just trusting the values they're showing them. So
right.
So if I go here for transaction, if you look right here, I can jump to a bunch of places. I can go to where it's actually defined, right? So that's the def module. But I can also go to the alias that brings that in scope. So in Elixir, in the AST, that that like the Elixir language server or the Alchemist server uses, because Elixir itself in the AST throws away that this alias came because of this line, you aren't able to jump of like, why the hell is transaction defined here? And so I'm able to do that because I do the walk on my own. And so that can be really useful if you accidentally chain aliases together and you're like, why the fuck doesn't this work? Like if I did...
Yeah.
Like I can jump to that and be like, oh, I actually double aliased. And so if anyone does it, I always recommend like, don't do chained aliases. You're going to shoot yourself in the foot, because I have. Like even if I had something underneath transactions here and I'm like, oh, I can be super efficient by doing another one here. Don't do that. and spell it out again, it's only going to lead to sadness.
Right.
Mostly because no one reading the code, including your future self, is going to be like, oh, if I see an alias, I should go up to the next alias to make sure that it's not chained.
Yeah.
It's not going to happen. Let's see. So I wanted to cover the weirdness of how. So this overview HTML, we said it's compiled, but in Phoenix, how is it compiled? So if these templates are somehow used in views, right? We kind of get that they're somehow used in views. So what we want is, yeah, this one's good. So we have the contract, we have the just contract view. So
Luke, quick question again, and somebody, I'm sure there's lots of opinions about this. Have you used VS Code before?
Haven't used it for anything yet. No, I've.
Wait, sorry.
The other ones I've used Atom because my wife uses Atom for some of her stuff, but I haven't used VS Code.
Microsoft owns both of them.
different-
So pretty soon they're going to be the same thing. It doesn't matter.
Different question. Is IntelliJ the best IDE you've used for Elixir?
I mean,
unbiased as you can.
No, because like the other ones have features I don't have because they're easier to implement. So like the other ones have docs lookup because they're just calling into Elixir and being like, give me the docs. So I don't have that yet because I want docs to work when you're typing the docs. So I want to instead parse the docs and then show them to you. And so everything.
Oh, I see.
When I get support for it, it works with errors, but it takes me way longer to do it.
Got it. Okay. So they have more features because they rely on tools that were built in Elixir for Elixir.
Right, which overall for the ecosystem is a good thing. If native Elixir had a mode for the compiler and tokenizer that like was allow errors and keep going, they could have like the reason why I wanted a grammar in the idea of like it works, it works when you're typing code. And that's what I wanted in the IDE. And also like the traceability of like the AST, if it kept track of like this thing came from this spot of, the aliases and the import, because, with a bunch of quoting stuff in Phoenix, there's a lot of magic of like, this doesn't work. Because of tail call optimization, my stack trace is gone. Where is this even coming from? And I want to be able to use go to declaration to not go to like the final declaration, but like all the intervening quote blocks that got me there.
Got it.
Because that's how I like to debug, is to be able to look at that. So looking going back to how does the EX templates actually get in here? So if we go to address contract view, is this Explorer web pulls it in. If we go down here to the view, we're going to use view, this root. So this use Phoenix view is saying, in your view, when you want to look for templates, look in this spot. And if we actually go to compiled view, so the decompiler was something I wrote. It's based on there's a website called Beam Wisdom that kind of explains how Beam files work, and it's based on that. So here, the cool thing you can do with the Beam files is you can see hidden functions that like don't show up anywhere. So there's all these hidden functions. Every module has an info where it's like sort of a reflection of like, you can ask a module what functions it has in it, because there's weirdly no standard, like it wants to be callable as code. It's not something that the runtime gives you of, I'm going to just introspect the bytecode to figure out what functions you have. It's an actual function that's defined weirdly. But there's all this stuff that Phoenix is injecting with like, should Phoenix recompile? And what that's doing is it's going out and noticing if the templates have changed. Here's a list of templates. And here's our render functions that we get from them. But then you see, we got some weird stuff going on.
Yeah.
We've got a function
index string, index.html string.
Yeah. So the string thing is because index.html would be a valid function name. So I decompile it in the format that would make it so you could actually copy this out and write as code.
Right.
Because this highlighting is working is because I'm decompiling the code, but then telling IntelliJ this is Elixir, which is why we get the do highlighting and stuff like that.
That's an atom.
Yeah, right. That's just an atom wrapped in quotes.
Yeah. It's because so the reason I know to do this is there's stuff in what is it? It's in special forms. So if you wait, sorry, wrong Elixir. Little Elixir. If you look in special forms, there's the use of like it wouldn't be possible to say def macro and a tuple here and have it work right. So it unquotes it to allow you to give a name that isn't really there. And this is only for the docs. All the special forms are special forms because the tokenizer and parser and compiler underneath the covers of is just Elixir AST has to mess with it. That's what makes special forms special. Is that it is not possible to implement this any other way than for the compiler to cheat and know about this function already.
Got it.
Weirdly enough, if we had support for var args, with wouldn't have to be a special form. With is a special form because if you think about it, it doesn't say how many commas you can have. Any number is allowed. And that's why like with is a special form.
Okay.
Is that the same for case?
Case might be a special form because case is compiled to case, like at the Erlang level. Case, I'm trying to think why it is that way. Yeah, I'm trying to think what's weird about case of why would it be, because case only takes one argument and then it takes a bunch of clauses, but case as a macro should work. Yeah, I'm not sure why case has to be a special form. It must be some reason. I'm not sure for case why it is.
Are we sure it's a special form? Because I'm not sure it is.
Maybe it's not.
I'll look it up.
Sure, case was a special form.
Come on, arrows. Hold on, I'm looking.
You
I'm
had a list
googling
of
it.
Special forms open, didn't you?
No, that was his.
Yeah.
Yeah, I'm not seeing it.
Oh, case is case. Case.
Oh, right, but it's a safe name. It's okay, but it. Yeah, I'm not.
Huh.
Like, I don't get why it wouldn't work as a macro though. It must be something to do with the compiler.
Right. Yeah, it seems like it would be an easy enough time to just replace do with of and then be like, you're done, right? Or do with end or do with of and then end with period and be like, you're done. But
yeah,
doesn't work.
Yeah, I'm not sure why.
At some point, as long as it works, you can be ignorant. And it's only once it stops working that you must know.
We don't have to know this. It works.
Yeah. So
I have I work with a whole team of people that
Everybody doesn't even know the company name they work for.
like this.
So that's
I have an appreciation. I have a definite appreciation for what he's saying, given I've flown on a plane before I understood like high and low pressure or anything, and I was like, we're going through there.
But that's like all your family members, they use a computer.
Thank you.
When they go, oh, you know about computers, right? And I'm like, well, I know about a segment of computers,
Right.
but I know more than you.
You know about computers? Yes, I know that computers are a thing.
Yeah, people pay me to do things.
Anyway,
Anyway, we were looking at this.
right.
With the case, or with the
No.
other one.
We were
so
looking at
with
review.
so with so this is the decompiled version. I figured that out first. Then I figured out how to do all the chunks. So the chunks are I mentioned this in a lightning talk at one of the conferences, but the Beam format is actually the format that EA used to use for its video game files.
Cool.
Yeah, and so like the magic characters at the beginning is like there's one letter difference between this used to be what EA used to use for like its packed video game format and like what they're using here. So it was some format in the mid 90s or something that they had. And so each of these chunks are just it's a length type value encoding. So like, you know, very simple binary formats with no compression are here's a type, here's the length of the thing, and here's the actual thing itself. Or sometimes they switch it around and they do length or type first. They switch back and forth what it is. So each of the chunks has a name. These names are like an actual string that's the start of them. The atoms used to be called atom. It's ATU8 now because this is one of those things that the Elixir team has contributed back to Erlang is Jose Valim for like a year had a PR open against OTP to, hey, it'd be really nice if we could have atoms with Unicode. And you're like, why? Well, XUnit, when you do like test and then a string, that string becomes a function name in the actual module when it's run. That's what the test macro is doing, is it's defined a bunch of functions with that big ass string you wrote. And so what would happen is someone would write the test case of like, you know, translates hello to
Right. This thing can handle Jose Valim's name.
right, and it couldn't as a function, and it couldn't as a variable, and so it would blow up.
Because there used to not be allowed to be Unicode characters in atoms.
No, it wasn't even like ASCII. It was literally the Latin 1 code page, which is like ASCII but with more Scandinavian characters, which makes sense for Sweden. And so ATU8 is the replacement for that. And there's actually like stuff in the beam where like when you ask for atom, it's going to actually give you ATU8 if you don't have an atom. But for that, you can see most of the atoms just show up in here. Cool stuff. By definition, the first index is always the module name. And of course, we see the Elixir dot because the reason why aliases are called aliases is because they're an alias to the atom with Elixir dot at the beginning of the name. So they're all here. There's also a set of strings. Now, the string pool is kind of weird, is that it is just a big, long string. The way it works is the code page, which I'll show in a sec, actually keeps track of like this index in that pool, and for this length, take a string. So if you have, if the strings in your file have some way to overlap, you can get a really compact string pool out of it. And the compiler kind of knows ways to optimize it.
Sorry, are you saying that, and I didn't know this, are you saying that Beam bytecode has string pools per module?
Yes. Yes, this is part of like this is reading the binary format using Java code I wrote. So this is like literally what's in there. Modules also know what they imported, which was a little bit weird when I first heard about. I think it helps with module reloading, though. But like every single thing you touch, it's in here, which could be super helpful if you're like, what the hell am I all using? Or if you want to be like, my compilers are bad, I seem to have a dependency I don't expect. You could use mixed xref or look at this. Exports are the exports in Erlang. There's a module attribute -export where you explicitly declare what to export. But for us, it's just the non-def p. So it's all the defs and def macros and the non. And so you can see those here. Lit is the literals. So it's a little bit weird is that there's both a string pool and a pool of literals where sometimes those things are strings. I don't know how the compiler decides which is which.
No, okay. No.
But here you can see the IO list thing of this weird thing where I render it where like it's a list, but I explicitly show the head tail thing is because this is an improper list. A real proper list would have a empty list as the last element. But an IO list is we're allowed to do just in Lisp what would be called a con cell of a head and a tail, where the tail at the very end doesn't have to be an empty list, which is in Elixir and Erlang are nil. And so you can actually see it working. And so like looking at lit can be a good way to see if you have things that are close but not exactly the same, you can pick up that like the compiler isn't optimizing the code correctly and isn't picking up that you're reusing stuff. So you can point out problems. What's other good one? So there's the xdocs. Like I can decompile it. I just can't present it to you yet, but you can see all the xdocs. XDP is new. That's the depreciation tag has a separate beam file, separate beam chunk, so that they can pull it out without having to like rescan the AST. So I don't use at deprecate anywhere here, so it doesn't show up. And this line thing is super cool of that it's this indirection of for any line in the file, you're allowed to say that actually coming from a separate file. Why is this cool? This is why. Because of this system of line references, even though we are in the address contract view module, it can know when it reports errors that no, you're actually in index.html.ex.
Oh, I see. So this is part. I see. So this is saying that this thing that was injected here actually came from index.html.
Yeah. And so if we look at the code, I have inline everything. So here's what the bytecode will look like if I turn off everything. This is like the raw bytecode. So here's a label. Here's some function info. I do the affordances of I always indent the functions because otherwise it's super hard to read all at once. But if we start to inline stuff, we can actually see where, so this is like, yeah. So the way it works is it jumps to some label, the line gets read, and then from that point on, if you have an error, the stack trace is going to report that this is the line it happened on.
Got it. So it just unwinds back to the line and says this is where it was.
Oh no, I think it's more like it has special tracking for line and like it's just keeping track of it in some storage in the C code.
Got it.
I haven't looked at it to be sure. But if we look here, so like here's contract view. If we go, so here you can kind of see the logic of give me all of my templates. And here it is embedded.
What tool is this, sorry?
This is my plugin in IntelliJ Elixir. There's if you click on a beam file, the text is the decompiled version of like just the functions, and the beam chunks, if you go to the code tab, you can actually see the bytecode.
Okay. And we're using this.
Luke, how long did it take you to write this decompiler?
A couple weeks. I mean, I only work on it at night, and well, with and Dockyard Fridays now with working at Dockyard.
Got it. That's cool, man. This is cool.
Yeah. I'm trying to. There should be a section where. Okay, here we go. You can finally see it here. Here you can see that this is getting into the index.html call now. And you can actually see us doing calls inside of index.html. And so when you're walking through, if any of these calls would blow up, like if our Poison code would blow up, it would get reported here, even though this code is only in the address contract view module. Like the template doesn't become its own module. It gets injected into other modules as code, and it's all right here. There's also things where it's constantly checking for if you're safe or not.
When you say safe, what do you mean?
Like the HTML safe. I'm trying to.
Oh, okay, gotcha. I wasn't sure if you meant like memory safe or something else.
No, although some of these calls do garbage collection if you run out. Like some of them have GC in the name.
Is that your battery or his?
That's my battery. Give me that gray bag right there.
Oh, right here. So here you can see is that there. So this function is going to. Okay, so here's the entry to index.html. If you say to render index.html right here, this is going to happen. We're going to. So if we look at the actual code for index.
Thank you for that, whoever mentioned it.
So we have to look at the actual code here. This render call on line 3 is right here, and you see line 3. If we look at the overview here, we're going to do overview HTML, render on that thing. So here, destination 1. So this is the setup of that. Explorer web address view is already in X0. Well, down here it is. And so here you can see like the little rearrangement that's going on, where we need to save 0 to 2, and then we're going to flip it, and then we're going to save 2 to Y. For the use of Y, I don't exactly understand. There are 2 classes of registers, X and Y. Almost everything. Oh wait, no, I do remember what it is now. Y is a register, but it's actually the stack.
So, yeah, what he said. What's that mean? Sorry. So you're saying that this is moving an atom from its table onto the stack?
Right. So this source here. So if I turn off inline literals. So what this is doing is it's saying the source is there's a way. So the beam bytecode is not the Erlang term to binary format. It's a compact version of that.
Okay.
And so what it's saying is the source here is literal 11, and it just so happens that the move function knows that literal 11
is
mean go in the literal table and look up 11. So right here you see it's overview HTML. And so when I inline it's overview HTML. And then this is it's gonna copy out the literal table. So there's no way for the bytecode to like inline literals. It is always going to be grabbing from wherever in memory it stores the literals.
Right. It's not a static. You're not looking at a slice of the built-in binary or something. Like you're not looking at a segment of memory that is.
Well, I'm talking more like how Intel opcodes sometimes allow you to embed, like if it's an immediate argument, like a small enough integer, it just becomes part of the opcode.
Right. Okay.
That isn't a thing that beam bytecode does.
Got it. Okay.
Oh, here, this is an is tag tuple. So right here, this is the check for like, is the thing that just came back from Phoenix Render a safe tuple for safe HTML? Right here, this is that check. So this is tag tuple is there because think about it. We use tag tuples all the time. Tag tuples are usually meant for like records. That's what we would think they'd be. And like, of course we don't use tag tuples, but the either type we use in Elixir, so like the OK success value or its error and reason is also a tag tuple. So there's a special bytecode to do that. And almost every single check sort of thing like is tag tuple has a fail label where you jump somewhere where it fails. So here's like, if it isn't safe, then we're going to go jump down to label 39. And so then it's going to check like, well, okay, what if it's a string? If it is a string, keep going, and then we're going to do HTML escape. So you can kind of see here, we're like, if it's not safe, HTML escape it, then jump ahead to 41. If you look here, if it was a tag tuple, it's going to get the tuple at 0, put it in place, and then jump to 41. So like, what this is doing is kind of like, you can almost see that the if in the background of, if it failed, go here. Otherwise, we're finally going to rejoin at the end of the if, or the closing curly brace for curly brace languages, and continue going. And here you can see the weirdness of the IO list where it's injected with the or.
Yeah, I'm actually curious why a empty string with something with the actual content being the improper part of the list. I'm wondering why that's apparently more optimal than doing something like just a list with. I guess it's because that other list has an empty list in it.
Yeah, I'm not really sure why.
Could it be that?
All I can think is that maybe it needs to be improper, like explicitly. Even though I thought the definition of IO data is like it could either be just a binary, or it could be improper. So
Right, exactly. Yeah, so what gets output with the IO data is either a list of binaries or a list of char. It's like char lists or lists of integers, right? Or sorry,
no, IO data is list of binaries or binaries or list of binaries. It's the other one that's a list of char lists, because this is actually binaries.
Okay, got it. So this makes me think that having the second list in there, even though it's an empty list, is like less efficient than putting an improper binary, like putting the binary in place of the improper. Putting the binary in place of the list. Like,
I mean, it could be an off chance that like the team hasn't actually noticed this and it is a missing optimization.
Oh, okay.
I have found those before because I do weird shit to Elixir.
Yeah. This so like, just so you know, this is pretty far out. I like this a lot though. To be able to introspect the beam code is pretty incredible.
So this
It was the reverse engineer.
Right.
Yeah. This somewhere I did have a thing on the Dockyard blog about it, and one of the cool things when I was first doing this was I always wondered, like, they're always like pattern matching is so efficient. Why? It's this select val is it allows it to map in a single bytecode instruction. Like, if your patterns all begin the same way, it can use this as select val and this list of stuff to go like, if it's function, jump to this label. If it's MD5, no, jump to this next one. If it's compiled, jump to this next one instead. And so it can very efficiently tell C, here's this list, do your magic, scan the list in C, and jump. As opposed to having to do a bunch of like equivalent, single atom comparison tests. This select val works on atoms like it's doing here, but it also can work for binaries. I'm trying to think if I can find another one that's doing binaries. There might not be one in here. It happens in oh right, it probably won't work with us being on call because it takes a lot of resources to render it, but the Unicode upcase file has like select vals with like hundreds of entries.
Right.
And that's why the Unicode thing is so efficient, and why we compile it, why we do it at compile time instead of like a runtime lookup, is it turns into a bunch of these select val calls.
Cool. Very cool.
So I don't know if they added it because I don't use the pry, but one of the nice things about doing my own debuggers, I'm able to trying to think if I can get this to run with us being on call. I was having problems compiling at the right speed with using so many resources. So
is it that you're I see you're gonna overheat your laptop, or it just goes slow?
It just goes really slow because it's using a full CPU just to stream, it looked like. Mm-hmm. Let's see if this is addressed contract.
So Luke, I have another question about, so when I was debugging, if I put a breakpoint in my test, because that is interpreted and it never turns into a beam, you can never stop at that breakpoint because you don't know it exists.
Right. So it's not me. It's the way the debugger works, and so the guy that maintains the Elixir language server now, Jake Becker, he did the original work on the debugger, and so he figured out from the IntelliJ Erlang plugin that the way they did the debugger is there's this system that actually powers, like, when you do debugger start for Erlang, internal to that, there's this module called int that stands for interpreted. And that's weird. And what it's doing is, I might not be in the right file for this. Can't tell. is that it's actually going to switch to interpreted mode. And what that does, and it's the weirdest damn thing and frustrated me so much because I did it after I figured out that, oh, the file knows that you're in index.html, is that it does not run that bytecode I just showed you. What do you think it does?
Pops up a new beam.
It uses a gigantic pattern matching from hell to directly interpret Erlang source code.
Right. It does okay, so it did stop here. So yeah, you can. So what it's actually doing is it can only interpret Erlang AST. So the thing is, do our beam files have Erlang AST? No, they do not. So what it does is, when another thing that Jose got with the like in the same period when he was doing the ATU8 thing was he asked for the pull that back up.
He asked for the beam files to include all of that information.
Well, he asked that it used to be that there was a thing that was like just the Erlang AST, but he asked, can we have this debug I chunk instead? And what it does is that when you do it, there is actually, this is a highly nested section. And what it actually does at the binary level of the very outer thing is a tuple that's like, here, call this module, and I'll tell you how to construct the debug format you want for your specific language. So the actual beam stores the like macro quoted form, but with like everything resolved. So like you won't ever see a piping up. You won't see the pipe operator in there. You'll see like what pipe looks like when it's expanded out.
Got it.
But for Erlang, to get the Erlang out, and therefore for the interpreter to get Erlang code to make it debuggable, it just kind of makes what's the equivalent. And the problem is the Erlang AST does not have the equivalent of line. There is no translation. So you know how the metadata for Elixir is like, here's the file I'm in and the line. In the Erlang AST, the middle metadata is one integer. It is literally the line. So there is no way with debugger and int to make this breakpoint work. So what my plugin is doing is a workaround. How it works is if you look.
I mean, wouldn't you just have to take and be like, if you find line in this meta, you just make that the meta?
Well, what I'm actually doing is.
Oh, sorry, that would mean you'd have to get inside of like the Elixir compiler while it's compiling. So I guess that's not a thing.
Plus so what it's actually running is when you do int, that thing is just full of pattern matches, and so there's no way to like change at least the Erlang AST that the interpreter. There's actually gen service called like debug server that is actually running this interpreted code, and it pattern matches on that being an integer, and like it cannot handle that being more complex than an integer, and it might also violate how Erlang abstract code works in general anyway. But because of that, how this works of why I can place breakpoints is when I hit a line, it's actually looking like I can get a stack trace. And if I get a stack trace that looks like the function is named for the template name, I'm like, oh, you must actually be in that template. You're confused. And I correct it and be like, no, go here.
That's a hack. That's cool. That's cool.
Yeah. Just one thing I just realized that not everybody here might know. In stock Erlang, every module is in one file, and every file contains one module. You cannot declare module per file in stock Erlang. That's why they were able to get away with designing the Erlang AST that way.
Yeah. See, I couldn't find the history when the line thing happened. It seemed that Erlang had it at a time. So there must have been some reason to trace like this came from another file. I think it's for the parse transform system to help with like I said, the Corba modules are all derived, and they had other things like like protobuf support. So like they probably wanted a way to be like to link back to like the original protobuf file
Right.
definition.
They have macros in Erlang.
They're called parse transforms because it's more like you're parsing. It's a different form of the AST and it's not as hygienic. It's closer to. Well, it's not as bad as like C macros because there are those too, but that's slightly separate than the parse transform system. The main thing with transform is like you get the blob of the entire module. There's no like I call the macro in a specific spot besides like textual substitution macros, which is what the question mark and then like a name is in Erlang code.
So does that mean that I have to change the extension of my whatever? What's the unit testing framework?
Oh, instead of EXS do EX. I'm not sure if that'll work. There's actually a thing on the Elixir language server thing talking about how to get the tester to work with tests. It's something about compiling them once as EX files and then as EXX files. I haven't tried it myself to see if it works.
I don't have a clue actually. So.
Yeah, no, because it was one of the things that I wasn't sure whether it is a deficiency in IntelliJ or is it a deficiency in the underlying system?
It's a deficiency in how int works. Is that int literally like tries to look on disk to find your beam file? Like you can't even like give it a callback of like, oh, I know you're going to look on this. Here, I'm going to fake the file. It's going to try to look on disk for the beam file, and so that beam file must exist or it's going to fail.
And that was the assumption that I made, that because if it's interpreted, there is no beam, so then I can't put a breakpoint in my test the way I normally would. I put where I believe the test is failing, and then I look for the very first time.
You can make Chris McCord does it in Phoenix. You can make directories that are used in your tests that are only compiled during tests. He does it for support.
Oh yeah. But this is talking about like if you want to put a breakpoint here, like breakpoints here like won't work because any Elixir script file doesn't generate a .beam file.
Right, but you probably could make a function that calls the break file.
Oh yeah, that totally already works. Like if I go into support and put not here because that's macro stuff, but if I put a breakpoint here, that'll totally work already. That's fine. It's this should stop here.
He's been right.
All right, man.
It's been great.
Right.
Thanks.
Okay, you're welcome.
We go nerves next month.
We'll do nerves next month. Yeah, I'll do it.
it.
Yeah, sure. No, I'll do my best. If you wanted to do it, let me know. You're always welcome, man.
He'll bring his Raspberry Pi.
Yeah. You guys should, get your boss to agree.
He agrees. It's selling into the business.
Yeah, right. It's a matter of practicality. It always is.
There's a couple of people above him. If we can convince them.
Cool.
Yeah, so this breakpoint works here. So support files will work because, of course, they're EX files, so they're really to beams. So those work. And yeah, that's usually my workaround. But I agree, it is annoying it doesn't allow us to do this because those modules exist in memory. So in theory, you could spit out the equivalent of beam if it would just allow to ask for it. But it's looking for real beam files. So the workaround is to fake it and to compile them as EX files and as EXS files, which is what the workaround from Jake's documentation says to do.
Cool. That's cool. Awesome.
The other thing I don't know if he's fixed it because I haven't looked at the language server recently, but one of the problems with the initial implementation he gave is it took forever to start up because the interpretation, because it's walking and running the AST every time and not optimized at all, it's at least 3 times slower. But a big part of it is interpreting all the modules. And so I had a thing where kind of like the predefined patterns in Phoenix, like the core libraries from Elixir, like agent access, but also stuff that comes from like DB connection are automatically turned off by default. so that your tests boot faster when you're running them.
Right. So you don't want to. Sorry. So what you're saying is usually it would be testing the entire runtime, and you're like, look, Ecto is not going to spontaneously break. File is not going to spontaneously break. We don't need to test these things.
Yeah.
Right. That makes sense.
It was actually bad enough that like with DB connection stuff, DB connection could time out. So like DB connection is when you definitely need to turn off. And so like I like this system because
I mean,
if you do it the other way where you opt in, you have to already know where the bug is.
Right.
Because if you don't interpret it, it disappears from the stack trace. Like things that aren't interpreted don't show up in the stack trace when it's paused.
Right. So what you're saying is if there was a bug in the enumerable module and you were using this, it wouldn't show up.
Right. So you need to it's in preferences a way to turn it back off. It's under there's a debugger thing.
Cool.
Themes debugger. No, I don't know where it is right now in the little menu.
No, that's all right. Well, I'm not sure if anybody here is using IntelliJ
I
anymore.
use IntelliJ for my bigger projects.
You do? For your bigger project?
My bigger stuff.
What's your bigger? What's
like a Authority Labs? I use
okay.
for everything there.
More important.
What's that?
I'm just kidding. Nothing. I'm only joking. Sorry.
Just when it's easier to start chasing code around when I can follow it, which I have an issue with VS Code. It just doesn't do it very well.
Yeah. Sometimes I'm like, okay.
Or like I've been working on a fucking 15-year-old Cold Fusion project on Monday and Tuesday, and that was IntelliJ was much more helpful with that than VS Code was, because it let me kind of refresh my brain and move around the project that I haven't touched in years.
Yeah, I mean that's the main reason why I started the plugin was my boss in my first job in Austin like got me on a RubyMine, and I was so shocked that an IDE could work that well on a dynamic language like Ruby that as soon as I saw Dave Thomas's talk about, well, I used to do Ruby and now I'm like interested in Elixir, I'm like, is there an Elixir plugin for RubyMine? And there wasn't. And I thought, oh, it looks like Ruby syntax. How hard can it be to implement the grammar again for Elixir? It didn't help that that part of RubyMine was closed source and like, you know, misunderstanding that the BNF isn't a universal grammar for that language. It is specific. Like there were so many things I misunderstood. It's good. I didn't realize that at the time.
Years later, it's actually this hard. It's years later hard, right?
Yeah, it's years later hard. So one of the new things I just released is that find usage works now. So like it used to be like you could go to a definition and like variables you kind of, but now functions you can do find usage, which I don't have full refactor, but like this will eventually will lead to like being able to rename functions too, because I can find and replace they're used.
I'll tell you right now, if you get that functionality to work reliably, I'll just buy IntelliJ and start using it.
I'm going to say.
Okay, well, so that's the other thing is that my plugin works in IntelliJ Community Edition, and that one's free.
This is too deep for me. This is meta. This is super. This is like meta, right? This is meta programming.
All right, it's almost like you went so meta you came back out the other side, right?
Yeah, this is cool though. I really dig this. I actually really like the decompiler because you're always like, is what I'm doing efficient, right? And now you can be like, let me just decompile it and look, and now you know, no, it's not, or yes, it is. Because I know for a fact that I'm guilty of. You kind of said it. You're like, as long as these patterns are the same, it can just do this select val. Yeah, I'm guilty in some of my libraries that are just like not using that. So.
Yeah. One thing you might like to know: aren't you the one working on the? This is really stupid that I don't remember. Aren't you the one working on the matrix multiplication library?
Yes.
Yeah, there's an IntelliJ plugin for Rust too.
Oh, well, there's a VS Code plugin for Rust.
Yes.
Yeah, all right.
But the IntelliJ Rust plugin hooks into the CLion debugger.
I've never had a bug in my Rust. I just sorry. I'm only kidding.
And the really dumb part is that the main reason I know this, one of the tools I wrote for my job, for part of our continuous testing pipeline, I wrote it in Elixir. It's used by the IntelliJ Rust developer. It's not used by you.
He's pointing at you, Luke, in case you didn't see that on the screen.
Don't ask me why. I guess it's just he heard of it.
That's cool. Oh, yeah, so I have to look into IntelliJ more because I've never, I mean, not that I've never.
Well, I came from RubyMine,
I used WebStorm for like a few weeks, and then some guy in, you don't want to get me started on this, but I won a license at a hackathon for WebStorm, and he never gave it to me.
Yeah, I started with RubyMine, and then when I was doing Android development, I went over to IntelliJ, and like I said, bigger projects I like it a lot. Smaller projects, I treat VS Code like or like Notepad or something.
Right. I hear you.
Yeah, I just really like the go to definition support with Command B. I like it a lot, and the super search is nice.
It's cool. It's definitely cool. Well, Mr. Luke, I think yeah, let's go ahead and call it, man.
Okay.
Cool.
Oh, the one thing I would say is some people complain about the memory on IntelliJ, and I don't know if you can see it, but down here you can adjust the memory.
Yeah, pass the flags in.
Yeah, so like this is how much it's using of the total I gave it, and mine is 7 gigs because I have like the entire Elixir standard library open when I'm like working on the plugin.
Mm-hmm.
But as far as I know, all the Electron apps don't allow you to set the memory limit. And so like when IntelliJ is slow, that's because they used to ship where it limited you to 750 megs, which is less than Slack eats. Like Slack eats over a gig usually.
Yeah,
so like you can adjust that value and make it perform better because it's a Java program. It knows how to stay in its bounds.
Yep.
And so like you can here edit custom options and change how much memory you give it in.
Got it.
And so like if it's behaving slowly, you can also turn this on. This is somewhere in preferences. I can find it later for people if they're interested. But that's a way to tune of like how much memory you want. It will actually listen to that because it's a JVM enforced memory setting. And you can make sure it stays well behaved or goes faster when you have a bunch of free memory.
Cool. That's awesome. Awesome.
I don't understand why you don't use Sublime Text instead of VS Code. Because that thing just opens.
So the reason
VS Code just opens for me. What do you mean? It
hold on,
opens?
I have an answer for this. The reason I use VS Code over Sublime Text, it's gotten better recently, but Sublime Text didn't have any commits or changes to its code base for like 3.5 years, and it looked like the guy abandoned the project. I had paid for Sublime. I have a Sublime Text license, right? So like, I still would use it. I just need to see it gain momentum again. Actually, like this. I don't know if I would use it at this point because I've been using VS Code for TypeScript, and that's what I do. A lot of, like I do a lot of my own front end stuff, and that's what TypeScript and VS Code are like.
Well, that's the thing. I don't
Jenny
use
and
TypeScript,
Gump,
so that's probably why I never saw the value in it.
Yeah. Other than that, I mean, it's got a lot of nice stuff, but I like it more than I like Atom, but that's only because I still feel like when I push keys in Atom, there's like a delay, right? I don't have that in VS Code. I don't have that in Sublime Text.
One of the things I read about IntelliJ is that they've got a custom code path just for typing, specifically to make sure there isn't any delay.
Oh, you mean like a thread? It's like dedicated.
Well, they've got a rendering pass just for the text field.
I see. So it shows up quick.
Yeah.
There's also like a crazy efficient, like the way the auto formatter works. So unfortunately, I implemented the formatter before mixed format came out. So like my version of the formatting is different than the standard one now. But if you look at that code, it has some crazy textual optimizations because if you think about it, for text, you're like technically rewriting the entire file past that point. And there's all this stuff because when Java first came out, like people were trying to write editors in it. Or like, text editing. So there's all these optimizations for how to efficiently in memory insert and delete sections of text without like killing off your
Yeah.
whole memory.
Sharing the screen or like right. That's
Yeah.
cool. That's really cool.
I
All
was,
right.
I would say one other thing is if you use a tool for Git, especially the built-in one in IntelliJ is super nice because they have a really cool tool for three-way diff. I can't simulate it with three-way diff, but there's this part. There's three-way diff. There's both. There is no conflict. Merge it in from the sides, but they also have now a magic wand merge, which is like if it can from the parsing figure out that, oh, you added 2 lines and they really conflict, it'll auto merge for you now. And they just added
Weird.
added patch support for commit. So if you do commit now, they have this system of checkboxes. So this is like patch but graphically, which I know like Git Tower and some of the other standalone tools do, but that's inside of IntelliJ now.
That's really cool. I like that a lot.
Yeah.
Cool, man. All right, Luke. Thank you for your presentation and your time and your wisdom. Anybody else got anything?
No, thank you. It was awesome.
Yeah, this is great. I like this a lot. I'm definitely so like this. Even if I don't use IntelliJ full time, I'm gonna have to pick up like a license or a trial or something so I can.
Well, like I said, IntelliJ community is completely free because that's the open source part of the library. It's Ultimate is like the closed source add-ons, and most of that is like extra Java enterprise stuff, and it allows you to get the integration. So like WebStorm is like the JavaScript stuff,
Right.
but if you get Ultimate Edition, the JavaScript stuff is included in IntelliJ.
Got it. So sorry. So from what Mike just said, IntelliJ is open
The
source or
community
free?
source is free. The community
The-
version is
yeah.
free.
Got it.
Part of
I
that
see.
came with when they
I see.
became
Are there
the official Android
I
IDE.
see.
They
So that
had
people-
to make it free.
right? That's part of the
So-
Android license.
Part of their deal
agreement.
with
Okay,
Google.
that's
yeah.
cool. That's cool. So
And that
I'll definitely
happened,
check
like,
it out.
way back in like
Awesome.
8.0 or something like that.
Awesome. Thanks again, Luke. We'll see. I'll see you around, man. I'll see you at work.
Yeah.
Yeah, man. Thanks again. Talk to you soon.
Yeah, so you only miss out on a few things of the paid version that you don't do for work.